Hi everyone, my name is Martin Linksfeld. I'm Master Chief in FoggyKitchen. Do you like cooking? I really do. And today we will cook some stuff in Oracle Cloud Infrastructure with the greatest tool ever, Terraform. Are you ready? This is the first lesson I have created, and it will be a lesson with real coding experience. I'm planning to start something very small. It will be a single web server, single virtual machine. It seems to be something very small, but still, there will be some additional work I need to do first, right? All machines exist in some kind of the ecosystem, in some kind of environment. In each data center, you need to plug power cord, connect the machine to one or more networks. Is that right? Here in the cloud, you still need to plan your machine connectivity. So there should be some network topology, some architecture planned before. We should clearly understand if the machine should be open to the internet, accessible there with the public IP, or maybe not. Maybe it should be behind the firewalls, accessible only through some VPN. All of that need to be planned upfront and coding within Terraform or provisioned manually. Okay, so let's jump into the first topology diagram of this lesson. Since that moment, every next lesson will start with incremental change on this kind of a diagram. Here is my topology diagram for the lesson 1. Please try to make yourself familiar with this. I'll give you just few seconds. On the next slide, I'll try to decompose this picture into details. Okay, let's decompose it. In this lesson, we'll create the simplest set of OCI resources, starting with one compartment, one VCN, one subnet in this VCN. Subnet will be regional, which means it will be covering all availability domains, 81, 82, and 83. Inside this public subnet, we'll nest one VM for the purpose of Webserver. Public subnet means that this VM will have public IP associated. This VM will be exposed to public internet via Internet Gateway and proper route table. After this deployment, one basic security list will permit access from public internet to VM via protocol SSH port 22 and via protocol HTTP and HTTPS port 80 and 44 free. For the purpose of the software provisioning, we'll utilize null resource and remote-exec capability of Terraform. Terraform will just install HTTP server with webpage content. As a consequence, after successful Terraform apply, we should be able to visit VM on the public IP address, and our browser will show us simple web page content. Welcome to FoggyKitchen.com. This is Webserver 1. Now it's time for some practice. Okay, let's start with code review. I'm using Sublime Text Editor with the add-on package to highlight HCL syntax. Code has been written in Terraform's HCL version 0.12, brand new. This new version helped developers a lot, mostly by simplifying syntax of variable interpolation and by loops and conditionals, which were previously very hard to code in Terraform. Let me open the first lesson. Lesson 1, Single Web Server. As you can see, we have here flat structure of the files with TF extension. I have splitted the code into separate chunks, and each file consists one OCI resource, but of course you can put everything into just one TF file. Let's start with the provider.tf file. This file is a fundamental part of our code. It will force Terraform to download OCI provider from the public repo. Additionally, we have instructed Terraform to use particular version of the OCI provider or even the higher one. On the other hand, the rest of the variables will be injected with the Unix environment. We will have isolated file where sensitive data will be stored as tfvars system variables. Okay, next resources in a row. Let's start with the compartment. It's rather easy. We need to define two attributes: the name of the compartment and description of the compartment. This compartment resource will be then referenced for each resource to be created, meaning all our resources will be associated with this compartment. The next resource will be VCN, Virtual Cloud Network. For VCN, we need to define CIDR block. We are not delivering this directly with the string, as you can see. Instead, we are creating interpolation to the predefined variable VCN CIDR. Definition of this variable is available in variables tf file here, right? So we will use range defined by 10.0.0.0/16. For VCN resource, we also need to define DNS label, display name, right? And it is also necessary to nest this VCN in compartment we have created before. This is the most practical example of the resource interpolation. Next two resources will be strictly related to the network topology and tightly integrated with VCN. The first one is DHCP options resource, and we will define here DNS name server and search domain names. In this place, you can stay with native OCI DNS server, VCN local plus internet, or you can create custom DNS configuration. In our case, it will be the first option. Let's jump to the next resource, Internet Gateway. This one opens the way to the public internet, of course from and into the VCN. This access to the public internet will be possible only with the proper routing. For that purpose, we have route table defined in route.tf file. As you can see, we define the simplest route where public internet, which is here, identified by CIDR 0.0.0/0, will be reachable via Internet Gateway, which is associated here and which we have created few seconds ago. But to be honest, a route table is not enough to enforce the security within VCN. We need to build security list. In security list, we define egress and ingress rules. For egress, it's pretty simple. With TCP protocol represented by 6, the traffic is permitted to go outside VCN into public internet represented by CIDR 0.0.0/0. For ingress rules, it's a little bit more complicated. We are using here HCL 0.12 syntax for dynamic blocks. I mean, we will iterate over variable service ports, which is here. This variable is defined in variable tf file as an array of the strings, right? For particular port. In our case, we will open the access to port 22 for SSH connection, right? And for ports 80 and 443, right? It means people from internet can access our web server. Okay, let's now integrate all of that on the subnet level. Subnet will be nested in particular VCN, right? And will be associated with predefined range of VCN CIDR block. In that case, it will be 10.0.1.0/24. Keep in mind one thing, we are not defining any availability domain here, as our subnet will be regional. Subnet also needs to have display name, right? And DNS label. Okay, and it should be somehow associated with our compartment, like the other resources. All previously created resources will be also associated here, right? Meaning we will have route table, we will have DHCP options, and of course security list applied to this particular subnet. Looks like cloud infrastructure is ready, so we can nest some VM here. Let's go to the webserver.tf file. For our VM, we need to choose the shape, which is here, and the image, which is here. Both of them are defined in variables.tf file. Okay, and as you can see, this time our machine will be deployed in particular availability domain. Even we have associated this VM with regional subnet. I'm sure you have also noticed two things. We have here a variable which is called public key OCI, and this variable will deliver the proper public key for SSH access, right? Also, we have permitted public IPs association to this machine, which means this public IP will be then exposed to us through VNIC, and we will be able to access this machine with SSH protocol. Also, we will see this public IP with output capability of Terraform. Looks like the code for cloud infrastructure and VM is ready. But I have promised that our machine will not be empty. We will have pre-configured HTTP server there. So let's deploy their Apache. For the purpose of this, we have last file, which is called httpd on the webserver.tf file. In this file, we will use null resource entity, right? And this null resource entity will connect to our machine with connection, which is here, and we have this remote-exec provisioner for that purpose, right? Look at here, we have delivered here public IP address of our machine. Inside the machine, we will install HTTPD package, right, with yum, right? Next, we will update the default index.html file with this content, right? Ultimately, we will disable the firewall, right? And we will start HTTP service. Okay, looks like code is ready to deploy. Here on the screen you can see my terminal. It is connected to the Terraform server. I will execute all of the Terraform code from this machine. But first, I need to create local Git repository with the copy of our course. Let me do it with git clone command and proper URL taken from GitHub service. Local clone seems to be successful, but I'm sure you have noticed, two other things other than directory with the curse. So we have this setup OCI tfvars.sh, and we have additional directory with credentials. Let me show you what we have inside the directory. So we have ID RSA, so private key. We have ID RSA.pub, which is a public key, and we have OCI API key with credentials to OCI. Please remember that we have all of those files here in this directory. And now I will show you setup OCI. I'll show you setup OCI tfvars sh. In this file, we will define tfvar variables in our operating system environment. All of that variables will be then injected directly into Terraform. They are somehow sensitive because they have data about our user, about our tenancy, compartment, and fingerprint, and some private key paths and our keys for the machine. So all of that shouldn't be inside our code, should be separated. Before we will move forward, we need Terraform, right? Because of that, I'm currently on terraform.io/downloads.html, and here I have a link for Linux 64-bit version of Terraform. And now I will download this binary, this zip file with wget. And I can unzip it. I need to now prepare the environment for running Terraform from each directory, which means I need to add Terraform directory where it is located into the path. So I need to check up current directory and then do the export path, current path, and add it here. And now I need to also source the setup OCI tfvars file. Okay, now I can go directly into the course directory and to the lesson1, and I can try to run Terraform there with plan command. This is the answer. The directory has not been set up. There is no providers which are required. So I need to run Terraform init with upgrade just in case. And now my directory is ready. In .terraform, I will have all necessary plugins. Which means I will have provider for OCI and null provider. Let me return back here, and I can type Terraform plan. As you can see, Terraform is planning to create 9 resources, and they are described above. You can see VCN, you can see subnet, you can see our secure list, which has been created with dynamic blocks. So we have 1, 2, 3 ingress security rules added by this loop. We have route table, we have internet gateway, we have the machine, and we have DHCP options, and many others which are necessary. Right now, we can run Terraform apply to create this infrastructure for us. And we'll type yes to perform all of that actions. It will take some time, so I will pause for a moment. After 1 minute, looks like Terraform apply has been finished, right? And we have these outputs here, and we have public IP address of our web server. So let us check the outcome. Perfect. We have the output which was planned. Let me check also the Cloud UI, Cloud Console, to see all of the resources. Okay, currently we have web server instance here. Let us switch to network. We have one VCN, one subnet with route table and security list. We also have internet gateway, and that's all. I think we can now destroy the environment. It will be rather simple. We will type terraform destroy. And we could expect that within 1 or 2 minutes, everything will disappear from here. I will pause for a sec. Looks like the destroy operation has been finished. 9 resources has been destroyed. So let's check up the console content. No items found in virtual cloud networks. What about instance? Yep, terminated. Our job has been done. This is the end of lesson 1. Thank you very much for watching this video. Hope you have found it interesting.